In the vast expanse of the universe, humans once thought that they were alone. They gazed up at the stars, wondering if there was anyone or anything else out there. But their searches always ended in disappointment. The idea of extraterrestrial life seemed like nothing more than a fanciful dream, a figment of the imagination. For centuries, humans searched the skies with telescopes and other advanced technologies, hoping to catch a glimpse of something, anything, that might indicate the presence of life beyond our own planet. But as time passed and their efforts yielded no results, they began to lose hope. The idea of encountering alien life became little more than a science fiction trope, a popular theme in books and movies, but not something that anyone really believed could happen. And yet, despite their doubts and skepticism, the universe had other plans. After all those years of searching, it turned out that someone was out there, watching and waiting. And when they finally decided to reveal themselves, it was in a way that nobody could have expected. Could this be the case? Or are we truly alone in this vast universe? In 1967, a young postgraduate student by the name of Jocelyn Burnell was conducting research at Cambridge University. She spent her days scanning the sky with a newly constructed radio telescope, hoping to uncover the secrets of the universe. After a few weeks of tedious work, something peculiar caught her attention. The telescope had picked up a radio signal that seemed to be pulsating, repeating every 1.33 seconds. At first, Burnell and her team dismissed the signal as mere interference, believing it to be a natural occurrence. However, the strange and consistent nature of the pulses soon sparked their curiosity. As they delved deeper into their investigation, the researchers realized that the signal was coming from deep space, and its precise pulsations were unlike anything they had ever seen before. The question that immediately arose was whether the signal was the result of a naturally occurring phenomenon, or if it was a transmission from an intelligent civilization. The researchers dubbed the signal LGM-1, an acronym for Little Green Men, in a nod to the possibility that it might be coming from extraterrestrial beings. Burnell herself couldn't help but wonder if she had made the groundbreaking discovery of the first signs of life beyond Earth. However, as time passed and more research was conducted, it became apparent that the source of the mysterious pulsating signal was not from an intelligent civilization. Rather, the signal was coming from rapidly rotating neutron stars known as pulsars, which emit beams of radiation that can be picked up by radio telescopes on Earth. 10 years later, in the summer of 1977, and Jerry Amon was sitting at his desk, staring at the printouts from the Big Ear radio telescope, feeling a little bored. He'd been combing through the data for weeks and had found nothing out of the ordinary. But then something caught his eye. It was a string of letters within a long sequence of low numbers, like a secret code hidden in plain sight. The letters spelled out something strange, something that made his heart race and his mind spins. He couldn't believe what he was seeing. Was it possible? Could this be the moment humanity finally made contact with intelligent life from beyond our galaxy? With trembling hands, Jerry circled the letters in red ink and wrote, "Wow!" next to them, thus christening the most famous and tantalizing signal in the history of the search for extraterrestrial intelligence. For months, scientists pored over the data, trying to decipher the meaning of the signal. But despite their best efforts, they came up empty-handed. Some joked that it was just a message from space aliens, ordering a pizza or asking for directions to the nearest gas station. Others speculated that it was a cosmic prank, pulled by a bored extraterrestrial teenager. However, despite many attempts to follow up on the find, the so-called wow signal has never reappeared. With each false signal, such as recent UFO reports, Oumuamua, and other unexplained phenomena, one can't help but wonder if the universe is simply playing mind games with us, or could it be that we are simply not looking in the right places? As of now, we have discovered over 5,000 exoplanets, with roughly 100 of them residing in the habitable zone of their stars. These exoplanets are prime candidates for further study and could potentially hold the key to unlocking the mysteries of life beyond our planet. NASA's James Webb Telescope is currently looking for planets similar to Earth in the habitable zone. But being in the habitable zone around stars is not the only condition for life. Sure, it's a great start, but we need other ingredients. Apart from water, we need an atmosphere that can regulate temperature and protect against harmful radiation from its star. We also need a magnetic field for shielding the planet from harmful solar winds and radiation. Let's not also forget that we need a moon. A large moon can help stabilize the planet's axial tilt, which in turn helps regulate the climate. But that's not all. We may need some certain ingredients which we may not know up till now. Okay, let's say there was once intelligent life thriving on another planet. What about the idea that they went extinct because they encountered a great filter? The Great Filter is a concept that attempts to explain why we haven't found any signs of intelligent extraterrestrial life yet. It's like a giant filter that all civilizations have to pass through to become advanced enough to be detectable by us. Think of it like a video game where you have to pass through various levels to get to the final boss. The Great Filter is like a level that all civilizations have to pass through, and it's really hard. Maybe it's a technological challenge, like developing interstellar travel or creating artificial intelligence. Or maybe it's a societal challenge, like avoiding catastrophic wars or solving problems like climate change. The idea is that many civilizations might not make it through the Great Filter. They might get stuck at some point, unable to progress any further. Maybe they never develop the technology they need, or maybe they destroy themselves in a catastrophic event before they get the chance. This is a scary thought because it suggests that the reason we haven't found any other intelligent life in the universe might be because civilizations keep getting stuck at the Great Filter. It's possible that we're still on our way to passing through the filter ourselves. Or maybe we've already passed it and are one of the lucky few civilizations to have made it this far. The scientists who subscribe to this theory point to the resilience of life on Earth. After all, life on our planet has already survived several filters in the form of mass extinction events. For example, the Permian-Triassic extinction, also known as the Great Dying, nearly ended all life on Earth. This event occurred 250 million years ago and wiped out about 96% of marine life and 70% of land species. While the exact cause of the Great Dying is still unknown, some scientists believe that it was a combination of warming temperatures and decreasing oxygen. But these previous filters, or extinction events, were natural, arising from the evolution of our planet and solar system, including volcanic eruptions and asteroid impacts. Now, however, humanity may be facing a great filter of our own making. This could be a threat like climate change, nuclear war, or some other human-induced catastrophe that could prevent our civilization from advancing to the stage where we can communicate with extraterrestrial life. So the search for alien life is a bit like a cosmic game of hide and seek. We're looking for signs of other civilizations that have made it through the Great Filter, but we don't know how many have actually made it. Scientists usually assume alien life will use familiar terrestrial biochemistry, and therefore hope to find alien life by searching near water or by supplying hydrocarbons. The assumption that alien life is likely to be based on carbon and water is implausible. For example, instead of relying on water as the solvent in which biological molecules operate, perhaps aliens might depend on ammonia or methane. And also, what if intelligent life isn't based on carbon, but rather based on silicon? Carbon and silicon are chemically very similar. Both of them can form bonds with up to 4 other atoms simultaneously. Moreover, silicon is one of the most common elements in the universe. For example, silicon makes up almost 30% of the mass of the Earth's crust and is roughly 150 times more abundant than carbon in the Earth's crust. Additionally, there are examples on Earth of organisms using silicon in biological structures, specifically in the form of algae known as diatoms. They are responsible for the usage of over 6 billion metric tons of silicon each year in Earth's oceans, as well as the production of almost 20% of the planet's oxygen. As a result, it is likely that silicon might exist as a stage of early life on other planets, converting their atmospheres into oxygen and getting them ready for more advanced life later on. Silicon-based life forms might thrive in environments that are too extreme for carbon-based life forms, such as high-temperature or high-pressure environments. For example, silicon is more thermally stable than carbon and can withstand higher temperatures, so a silicon-based organism might be able to survive in a hot volcanic environment where carbon-based life could not. Silicon-based life forms would have to use more energy to maintain their metabolic processes and are less able to quickly respond to changes in their environment. Despite the many uses silicon has for biology on Earth, the chances of it being the major building block for life here or elsewhere seem to be low. There are also scientists who believe that life could be based on non-carbon and non-silicon elements altogether, using elements such as sulfur or phosphorus in their biological processes. In these hypothetical scenarios, life would have very different chemical and physical properties compared to life on Earth, and would likely require completely different conditions to thrive. Maybe we haven't found alien life yet because their technology is so advanced that it's indistinguishable from nature. Maybe alien life exists in a form that we haven't even considered yet, like beings made of energy or living in an environment completely different from our own. Maybe intelligent life is out there, but it exists in a different dimension or parallel universe that we haven't discovered yet. Maybe intelligent life is waiting for us to reach a certain level of technological advancement before making contact. Maybe the universe is teeming with life, but we just haven't looked in the right places yet. Maybe intelligent life exists, but it's so far away from us that we'll never be able to make contact. Maybe intelligent life exists, but it's not interested in making contact with us. And maybe, just maybe, we are the only life form in the universe. The thought of being completely alone in the vast expanse of the universe is enough to give anyone a chill. It means that the responsibility of preserving and advancing life in the universe lies solely on our shoulders. Civilization and consciousness are like tiny candlelight in a vast darkness, and a very vulnerable candle that can easily get blown out. We should take great care with what may very well be this tiny candle in this vast darkness and make sure it does not go out.